Hello everyone, my name is Fitri Endrasari and today I'm going to present you the experiment that I have done for one of the courses that I take this semester, which is Senior Mechanical Laboratory, or we often call it as SML. I would like to apologize for not showing my face on the screen because my current condition doesn't allow me to do that, but here I put my photo when I did the experiment. So the title of this presentation is Study of Thermodynamics, Heat Transfer, and Fluid Mechanics Principles, an experiment using hairdryer. Okay, before I explain more about the experiment, I would like to give you the general flow of this presentation. Here I show you the outline of this presentation. So in this presentation, I'm going to show you the introduction of the experiment, its preparation, assembly, experiment analysis, conclusions, and last but not least, at the end of this presentation, I'm going to give my feedback on SML class. So now let's move to the first section. The first section is introductions. In these sections, I'm going to show you why we did this experiment. Actually, SML should be done in campus laboratory. However, we cannot do that due to COVID-19 pandemic. That is why in this semester we have SML from home. For SML from home, we should come up with an idea of experiment that uses the principles of thermodynamics, heat transfer, and fluid mechanics. To do this, we are working in a group and my teammates are Dara and Yeti. To fulfill the basic requirements, we choose an experiment using hairdryer as our theme. Next, I'm going to show you the preparations of the experiments. There are basically three things that I'm going to explain related to these sections, which are experiment design, shipping, and purchasing components. For experiment design, in this experiment we use a paper by Robert Edward from the Pennsylvania State University at Erie entitled A Simple Hairdryer Experiment to Demonstrate the First Law of Thermodynamics. To do this experiment, there are tools and materials we should prepare. Here we have hairdryer, pipe, tape, vernier caliper, two thermocouples, a scale, an anemometer, rice and paper cylinder, and of course I always have notes to record the data during the experiment. For shipping, there are three scenarios. Scenario 1, each of member will start an experiment at the same time with one principle each, then they should exchange the equipment until everyone did the experiment of another. For scenario 2, we should find an experiment that uses the principle of thermodynamics, heat transfer, and fluid mechanics in one experiment. Then we pass the equipment to our teammates. For scenario 3, it asks us more likely to be an independent experiment because each member will perform the same experiment that uses the principle of thermodynamics, heat transfer, and fluid mechanics. In this experiment, no shipping within the group. For my group, we decided to choose the second scenario because it is more affordable and we don't need to perform many experiments. Then, for purchasing the components, we did it in two ways, which are online and offline. For online, we bought the equipment from Shopee or Tokopedia. For offline, we bought the equipment from Multilab Jogja and Common Store nearby. The next section is about the assembly of the experiment. So now I'm showing you the setup of our experiment. As you can see here that the pipe and the hairdryer is connected using tape, and there are two thermocouples, one at the inlet, so this is the inlet of the pipe, and one at the outlet of the pipe. The data will be taken once the thermocouple shows a constant temperature. Then I will move the thermocouple at the outlet, then put the anemometer there. Same goes with anemometer. The data will be recorded once the screen shows a constant velocity. Then I will repeat the experiment 3 times to get more reliable result. Now I'm going to explain about the experiment. In this section, I'm going to explain three things. First, I'm going to explain the working principle of the setup. So, as you can see on the screen, when I turn on the hairdryer, the air will flow from the inlet to the outlet. While the air is flowing, the thermocouples will measure the temperature at the inlet and outlet of the pipe. Next, I'm going to explain about the data collections. So I did the experiment 3 times and I took the data from each of them. The data are tabulated in the shown table. This data will be used to analyze the experiment using the principles of thermodynamics, heat transfer, and fluid mechanics. Also, from this experiment, we are expected to study how the principles of thermodynamics, heat transfer, and fluid mechanics are applied to hairdryer and understand the effect of each parameter in hairdryer performance. Now we are going to move to the next section, which is analysis. For thermodynamics, we use the first law of thermodynamics. By neglecting the potential energy within the system, the energy balance equation for this experiment is shown here. The goal of this experiment is to find the electric work on the hairdryer. Therefore, we use the equation for heat from heat transfer and finding the mass flow rate at the inlet and outlet of the pipe using the principles from fluid mechanics. Once everything was found, we can determine the value of the electric work in watt. So these are the results of our experiments. The results are different because we performed the experiment under different conditions. For me, when I did the experiment, I couldn't make the hairdryer at its full speed and heat. The electricity in my house cannot bear that. That is why, in this experiment, I only use medium heat and velocity, while Dara and Yeti use maximum heat and velocity. The presentation's coming to an end. Now we are at the conclusion section. So for this experiment, there are basically two conclusions that we made. The first one is that the power needed by the hairdryer increases as the velocity and temperature increases. And the second one is that in any experiment, it will be better to repeat the experiment to get several data so that we can get more reliable data. Now it's time for me to give my feedback for this class. Actually, when I decided to have this class this semester, I have imagined how I will have an experiment with my friends in the lab. Unfortunately, the current condition didn't let us to do so. Thus, here we are, having a special SML course, SML from home. While taking this class, many memorable things occurred. From the first step when we should determine our experiment until we make a video presentation like what I did right now, every of them is unforgettable. This course also challenged my understanding about the courses that I have taken, which are thermodynamics, heat transfer, and fluid mechanics. This course also taught me how important it is to have our equipment ready when we are going to perform one. I did it during my experiment. I forgot to take the rice. Thus, I should go find it, then repeat the experiment from the start. Also, I find this course is very challenging and fun at the same time. Together with my friends, even though we are not in the same place, we could do and learn something same. It teaches us how to be creative in any condition as a mechanical engineer. I hope that other students who will take this course next semester or so also find this course interesting. If they are destined to have the same special class as us, I hope they won't get discouraged. I did, as well as everyone in our class, so there shouldn't be any space for discouragement. Lastly, I want to thank Pak Jati for giving us a chance to experience this, and my teammates, Dara and Yeti, for always being supportive teammates and sisters. Thank you, everyone. Okay, I think that is all from me. I hope you can find my presentation helpful. Thank you and have a good day.